Yes, thank you for the invitation and for the very kind introduction. I have a sort of a difficult task first because the previous speakers have really broad knowledge of the ERC scheme, and I have so much experience with seeing so many applications and working with the ERC. And I have just one data point that I can talk about, and second, it's kind of difficult because I was asked to also say a few words about the scientific part of the project. I will try to say something about the math, but that is just to give you some idea. It's quite difficult in pure mathematics to give a broad audience sort of overview. Okay, so this is the raw data point. This is the title of my grant, and the acronym is capybara, which is this animal here. And it's based here in Warsaw at the Institute of Mathematics of the Polish Academy of Sciences. So that was the ERC 2018 call for the starting grant, which means I had to apply in 2017, and the grant started just now, actually in June. Okay, so let me tell you something about the sort of the story behind this grant, and I think the most important question, maybe from the perspective of a future applicant, is the question: how do you arrive at the research idea that's worth writing a proposal, or rather, how do you know that you're ready to apply for a grant, or how to make an idea into a proposal? And so I will try to sort of show you some example of this. Professor Rowiński already went through my sort of short academic CV. So I applied for this grant just 2 years after my PhD, so that's the earliest possible date. So I was very lucky to get it at the first try. Maybe about this CV here. For me personally, it was extremely. Oh, thank you very much. It was extremely important that I studied abroad and did part of my postdoc abroad because of the scientific connections that I got there. So I did my master's in Warsaw, so I already had done some research, unlike many of my colleagues in the graduate program in the States, because they're usually the undergraduates don't know as much as our graduates, as our college graduates. So what was difficult for me was actually to shed some of that experience that I had from Warsaw. That I already had a prior research experience, so it's like when you have a hammer, then everything looks like a nail, and so. So I was sort of stuck in my my former academic interest, and I had to go out of this. And it took some years. I still was finishing some project that I started thinking about in Warsaw. It was all for good that I managed to change my sort of academic interests a bit, and I think had I stayed in Warsaw, that could have been much more difficult. Okay. So what made me think it was time to apply? So for me, it's the sort of the narrative behind this was quite easy. I obtained a single result that, unlike in many cases in mathematics, you cannot, or in science in general, you cannot maybe state an idea in one sentence. Here I managed to. You might not know what the k-pi1 space is. That's okay, but still, it's just a single result that made me immediately visible. Before that, I was writing some papers, but didn't get any really invitations to conferences. So this was just one thing that made me visible and got me a publication in a top journal very quickly. So it all made everything much easier, especially that in math, when you submit a paper, then you wait maybe for a year or even 2 years before you get a referee report. And here it was much quicker, so that's why I'm saying I was very lucky. And what's very important is that this result was sort of surprising and unexpected, and it led immediately to new questions that I wanted to explore. And so this was the point when I started thinking that maybe it's time to apply. I mean, I think maybe with those grants, I mean, of course you write 5 + 15 pages of a technical proposal, but I think that sort of the narrative is very important. Like here the narrative is, I had this result and it led to these questions. Sometimes you can have a different type of narrative that suits you well, but at least it should be something other than, yeah, this person is clearly very strong and they had these publications and they will do more of the same. This doesn't cut it, really. Okay, so about the proposal, let me tell you a few words about the process of writing this proposal. It was a very painful process, and yeah, it's hard work, really. And then I will say a few words about the scientific aspect of the proposal, so the science behind it. So the application process, I mean, I started not extremely early. I really started working on it in June 2017, so that was 4 months before the deadline. And that was actually quite late. And the first step that you should consider is actually talk to colleagues who have had success in ERC grants and just ask them to see their proposals, because it will be very inspiring for you to see a proposal, even if it's not your field, even if you don't understand the scientific aspect, you'll see like what kind of work it is. Actually, in Poland, it's quite helpful because the National Science Center has programs whose format is kind of similar. So if you already applied to the National Science Center, then you already sort of have an idea what the proposal should look like. But actually in the ERC, with this high risk, high gain sort of stress on the high risk, high gain aspect of the proposal, it's really quite different. So the second step is that you draft a short summary. I think it's much better to first start with the part that will be read by this broad panel, and that has to be perfect, because if it's not perfect, it will not go to the second step, and so nobody will read your 15 pages of your technical proposal. And it's important to run it by as many people as possible and send, ask them to send you their comments, and treat really their comments very seriously, because they know, I mean, it's important to treat the feedback very seriously. And I have run my proposal by maybe between 10 and 20 people. Many of them were ERC grantees, many of them were experts in my field. So that has been tremendously helpful. I also did that to some extent with the full proposal, but that's 15 pages of a really technical stuff, so you can really only show it to experts, or, yeah. And then you submit and wait, of course, and then you prepare for the interview. That's a different story, and somehow it's sort of, this interview part is a bit like a sport. I mean, you have to train, like you have to make your presentation fit in the time requirement, and so my advice is you should not think about it at all until you get the invitation to Brussels. Yeah, and so the bottom line is you should ask for help from like as many people as you can, colleagues and your host institution, which might have some ways to help you, especially with the budget. This wasn't really the case in my situation, but I got some help from this the Office for Scientific Excellence at the Polish Academy of Sciences, that the people who organized this wonderful workshop today. Okay, so now let me tell you a bit about my field. So my field is arithmetic algebraic geometry. So the picture sort of explains this in the words that are sort of uses concepts familiar to you from school. So geometry means, let's say, I want to understand geometric objects, but are defined. So algebraic geometry means I want to understand geometric objects defined in an algebraic way. Like the circle is defined by this polynomial equation of degree 2. And arithmetic hints us at a link to number theory. So what if in this equation we consider x and y not to be just real numbers or complex numbers as you would usually do in algebraic geometry, but rather, say, rational numbers. So for example, you also know from school that 3/5 and 4/5 gives you a point on this circle because 3 squared plus 4 squared equals 5 squared. So in my project, I want to understand what's called in the title homotopy types, which are roughly shapes of such algebraically defined geometric objects. So that's the goal, and this has really links to many things in mathematics, and some of them outside of mathematics. I already hinted at the link to number theory. It's actually quite surprising that number theory is sort of very algebraic and formal way, and formal field where you don't really expect to see much of geometry, but I mean, the last 50 years have shown that actually geometry is everywhere, and in particular it's really present in number theory, and also it has links to mathematical physics. And what's really exciting to me personally is that actually my field provides some kind of, somehow, a common language, so that these very far away disciplines like number theory and mathematical physics can talk to each other or exchange ideas, which is, I mean, very surprising. I have no explanation why that should be the case. Okay, so here is some abstract art. Here's some more abstract art. So this is a diagram actually from my research proposal. I'm just showing it to you as just an illustration of the project architecture, which is in my case very complicated. I call it an octopus type project, where we have a central sort of idea that we want to sort of explore in different directions and look at the connections. But your proposal could have, your project could have a very different architecture, where you want really to go from point A to point B through point C, D, and E, where you have clearly defined steps. That wasn't the case in my situation. And just briefly tell you about what I perceive as strengths and weaknesses of my proposal. Of course, I will never know what really convinced the panel. So the strengths are that, as I said, this was really, the narrative was easy. This was based on a single result that you can fit in one sentence. And what I like to do in mathematics, I think it's exciting in science in general, when you combine, is the sort of alchemy aspect, when you combine sort of different things and something new comes out of it. And so this was I think a strength, and I had some even though I was early after a PhD, I had pretty clear scientific independence, because I really came up with the research ideas. I mean the questions that I was working on myself. So in that sense, that was the easy thing to claim in the proposal, that I'm scientifically independent. The weaknesses is that, yeah, some of the research goals had kind of speculative nature. Like, I could not really formulate a precise research hypothesis, and that I felt like it has not been the case that the referees had a problem with that in the reports, but I felt bad about this as a potential weakness of my proposal. And then the project architecture, as you have seen on the previous slide, was kind of complicated, maybe too complicated. And I mean, so this is a graph, and you can see this graph is connected. So that's a good thing. If I had two connected components where you cannot go by some arrows from one point to another, that would have been really bad. And so it started disconnected, and I worked hard to make it look like it's more connected, but still it's really spread out. So that's a potential weakness. And yeah, and I was very early after PhD, so I didn't have any experience being a PI, and well, especially if you look from perspective of other fields, I had like 0 bibliometric indicators, basically. Yeah, so now a few words about the implementation. Yeah, the team is me. Now I have 2 postdocs. They just graduated. I wrote 2015. It was supposed to be 2019. So they both just graduated, got their PhDs, and started working with me this summer. And then I will have 2 more postdocs and 2 PhD students that I will hire in future years. And we have some activities, like we just organized a conference on arithmetic of differential equations last month. We have a weekly research seminar and junior algebraic geometry seminar to attract students. So what I think here you should remember from this slide, well, from my comment on this slide, is that you should be very, especially if you're from Poland, you should be very active in trying to find competent people that will come to work with you. It's not like that easy that you have an ERC grant, so you just post a job announcement and you have like so many applicants. It's not the case, because even though I can pay an okay but not great salary, and cost of living in Warsaw is much smaller than in the Western countries, people typically do not consider Poland as a place where you want to go to do research for your postdoc. So I had to do some convincing and actually talking to people in person that I think that would be great for the grant. And I was in this first year of the grant, I was actually quite successful, and especially the American postdoc seems to be happy in Warsaw, so I'm very happy for him. Yes, and now about the sort of the support for the grant. So I have an administrative assistant that was part of the grant agreement, maybe working around quarter time. I mean, that's a must, and it's not automatically great. I mean, my institution does not have much experience, much experience with ERC grants, and I don't feel like they are sufficiently proactive in trying to take the task. If I ask them to do something, they will do it. But like, for example, if I'm organizing a conference, I do everything myself except for like booking hotels that they do for me. So it's, yeah, it could be better here. But still, I mean, I will not complain that, I mean, they are doing their best, really. And then one thing that's, I think, really crucial is the matching fund for salaries from the Polish Ministry of Science. Because under the Horizon 2020 rules, and maybe under the rules for the next framework, you cannot pay a higher salary that is the typical salary at your institution. Which means, for me, that my salary after I got an ERC grant has dropped. Because I get the same salary, but now it's paid by ERC, but I cannot get, for example, another grant that would pay me a top-up on my salary. So with a plain ERC grant is just, is this bad? And I mean, not speaking of my own salary, it would be impossible to attract foreign postdocs with the Polish salary. Actually, I think, by the way, that we are having sort of some discussion a bit backwards because we are talking about the ERC applications, but the sort of the source of our problem is that the salaries are so low. And before we fix that, then I'm not sure much can be done. And in this particular case, there is this program from the Ministry of Science that actually only makes this a reasonable idea to have an ERC grant in Poland, at least at my institution, without this top-up, which is a considerable amount of money, just for the salaries that I can top up my salary and my postdoc salaries. It would not be feasible to have this grant at my institution. I mean, had this program just disappeared, and actually when the ministry was changing the law last year, the program just mysteriously was suspended. It was right when I was signing the contract with the ERC, and unfortunately it was unsuspended, and then I applied and got it. It's automatically given to ERC grantees. Had they not done that, or had they like suspended the program indefinitely, I would have to move somewhere else. Yeah, so just to finish, what are the key takeaways from the talk? So the first one is, have this idea in the back of your head when you do science, like, is this idea a possible gateway, or is it could I formulate this idea as the sort of make it a foundation of my future ERC proposal? There are some pitfalls, as I explained, with first with the administration, and then the second with with these salary rules, which can be a bit problematic, and I think it's okay to apply early, because the panelists, I think they realize that you have applied just 2 years after your PhD, and in any case they are not really interested in your Hirsch index or the sum of the impact factors of your publications or anything like that. So, and I think as we've talked yesterday during dinner with Professor Bourguignon, this is also the case with, for example, the synergy grants, where the average age of the applicants is actually pretty high, but the success rate across the spectrum is sort of roughly constant. So this means that people are afraid to apply because they think they are not senior enough, and they look at who got the grant, and these are really really well-established people, and so they feel maybe it's not for them, maybe they are wrong. Okay, so thank you very much. Here's the animal again.